3.5.
So would we have to double the value for our distance travel?
In this particular case, yeah, since he does pass across the starting point, yeah, that would double and then plus this.
Okay.
Do 50.64? Do 60, did I lose one then? Yes, because 1 plus 8 plus 8 plus 3 is 20. Okay, 260. All right. Now we take this one step further. What's the average speed? How would you find it?
Isn't it like distance traveled divided by, like, I don't know.
Time.
Yep. So my average speed is the distance traveled.
Divided by 11.
No, yes, sorry, I lied. All right. $24 meters a second. What is it?
23.69 or 5.5. Yeah.
What is its average velocity?
$23.69.
Not negative 23 point, no.
You probably said that because you have velocity average written.
No,
Well, we did the.
this is not velocity. How do you know this is not velocity?
Oh, because there's not a
Not a
particular,
direction.
okay, that's speed,
Yep.
okay.
The vector symbol, they still use the V for speed, but there's no vector symbol over it if we're talking about speed. Average velocity. How do you find average velocity?
The total distance traveled in,
No, I'm gonna stop you there.
no?
There you go.
Okay,
Velocity is displacement over time.
gotcha.
There's another way of doing it, but we'll do that for now. So average velocity, vector symbol, is negative 203.5 divided by 11.
It's negative 18.5. Meters per second.
Okay, questions up to here, because I want to take a look at average velocity a slightly different way.
That's velocity we just calculated,
Yes, average velocity.
average velocity, okay.
Will there be a question with this many parts on the test, or are we just doing this for
Oh,
demonstration?
I would not be surprised if there's a problem with this many parts,
Okay,
and then anything else I can think of as I'm writing it.
Good to know.
Well, minus the stuff I forget about as I'm writing it.
yeah,
Will we have a formula sheet on the exam? Or
If you look at the old test, at the very top of the first page are the formulas.
Okay,
And so if you want formulas besides that, those you'll have to memorize.
gotcha.
Or put in a request enough to let me make a judgment call. Generally, what happens on the quizzes and tests, most chapters have a summary section, and so any formulas in the summary section, generally are gonna be on the quiz and then subsequently on the test. The form that is in the textbook sometimes is different than the form I do in class, and so in that case, I will put the book form and then my form. Because I think the book writes these a little bit differently, so I have this version and then whatever the book has.
Gotcha.
Unless there's a groundswell for not doing that, because you need to show that you have memorized them all, and I'm glad to take them off. unless there's a groundswell. That's the way it is. All right, let's take a look at a different problem. Initial velocity of, let's make it 15 meters per second, and acceleration, constant acceleration of negative 3 meters per second squared. And let's let time be, I'll stick with 11 seconds. Actually, 12 seconds. So time in seconds and velocity in meters per second. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The problem's gonna last 12 seconds. My initial velocity is 15 meters per second. And my acceleration is negative 3 meters per second squared, which means negative 3 meters per second per second. My velocity is gonna change every second by negative 3.
So, so it's like 12, yeah, 9, 6, 3, 0, negative 3, negative 6,
But I'll try to, negative 6.
negative 6, negative 9,
Negative 12, negative 15, negative 18, negative 21.
All right,
They sort of converge in the middle there.
what?
all right. So let me, sort of draw a few dotted lines here just to. So it stops at 5 seconds. Or we could have plugged into the first formula over there and done 0 is equal to 15 minus 3t and t is equal to 5. But I have the time it stops. Now, when I'm talking about average velocity, I've got all these numbers right here, and we can average it the way that we were taught. So if we average these numbers, you add them up and you get negative 39. And then divide by
11,
12.
12, sorry.
neither.
13.
There's 13 numbers here.
0.
Yeah. Well, it's a common mistake for people to do it this way, is forget the fact that there are 13 numbers there. Divide by 13 and you end up with negative 3 meters per second. Now this works because my time intervals are the same. If I did 0.5 then 2, then you can't do it this way. But what's special about every 1 second?
It's always constantly changing, I think.
Yeah, but if acceleration's constant, I can get rid of all the odd ones. Add those numbers up, and I get negative 21, divided by, well, I've got 1, 2, 3, 4, 5, 6, 7, I got 7 numbers now, and I get, no, the same answer.
With less things.
Hey, isn't that meters per second squared?
No, it's average speed, average velocity.
Oh,
I'm adding up meters per second, just dividing by a number here, this is an estimate.
right.
So average velocity is the same as acceleration.
No. Oh, coincidentally in this problem, yes.
Okay.
The same negative 3. All right, but what's so special about every 2 seconds? Why not every 6 seconds? So I add those up, and I've got
Negative 3.
Negative, no,
Yeah, negative 3 over 3.
negative 3 over 6. 15 and negative 3 is 12, minus 21 is negative 9.
Oh, negative 3. Sorry, I thought that was like a long.
Negative
Oh,
9 divided by
okay.
3.
So I get negative 9 divided by 3 this time, and I get, whoa, I get the exact same answers I got over here. And then what's so special about every 6 seconds? Why not just, why not just do the first and the last one? I can add those up. We actually did this earlier. Right there. The average velocity, if acceleration is constant, the average velocity is just the average of the first and the last one. So instead of doing displacement over time, which is legitimate, we could also have just done 20 plus negative 57 divided by 2, and we get negative 37 divided by 2, which is negative 18.5 meters per second.
Do we need to multiply that by time?
Nope.
Oh, wait, never mind.
If acceleration is constant, it really doesn't matter how much time it took.
Well, so that, the equation that you just used with the delta x equals, yeah.
Yep.
That one, so that's average that's average velocity?
Times time.
Okay,
To get displacement, I need to multiply times time.
okay.
But if I manipulate this slightly, and I recognize the time, if I divide by time, I get delta x. Doing that left-handed more often. All right, I get the displacement divided by however much time took place is equal to VI plus VF over 2. Basically, this first part right here, that's what we did here. The second half is what we did right here. They should be equal to each other again, if acceleration is constant.
But weren't you saying that whenever we see velocity, we have to assume that it's instantaneous?
Yes,
But what we just did was average.
yes, because I threw the word average in there, that suddenly I'm not looking at the overall thing. But when I find average velocity using this part right here, the VI plus VF, this is the instantaneous initial, the instantaneous final, divided by 2, gets me my average. All right. And I guess on that note, you'll have the weekend to rejoice in your room.